Hello friend, welcome to Network Lab Room. This video today allowing me talks about some concept and terminology first. The reason why, because with me learning CCNA not easy. It's a long journey that require a lot of power, patience to complete, and we always need a boy for starting this journey. I believe starting with concept and terminology is a good choice. It's a fundamental step to understand networking and help us move further as well. Of course, it also requires spending a lot of time for practicing in lab, working in a real production environment, and importantly, never stop learning. The first concept I would like to mention is TCP/IP and OSI models. Why them? Because they are foundational in the networking, and understanding them is important for anyone studying CCNA. Once upon a time, the world did not have any networking protocol. A vendor created the first network protocol supporting only their device. So, let's imagine if your company buy a computer from different vendors and somehow connected your network, then making combined network so much more complex, right? So, TCP/IP and OSI were born to allow communication between devices of different vendors. OSI models is published by International Organization Standardization (ISO) and TCP/IP created by two researchers. They work for Defense Advanced Research Project Agency. Okay, let's start with TCP/IP. Turn back in time. TCP/IP first published in 1973 by Winsor and Bob Kahn, most often called the father of the Internet. That year, they begin research how to transfer data on the radio network and then release the first version transmission control protocol. And in 1974, they created the next version of TCP, include the Internet Protocol term. After that, in 1990, TCP/IP is standardized at the request for recommend 761 and is still used today. TCP/IP is separated into several layers. Each layer has specific function, include protocol and standard that related to those function. Original TCP/IP has 4 layers. The top layer focus more application that need send and receive data. Bottom layer focus how to transmit bit of a link with the internet. Layer focus on delivering data over the path from sender to destination. And the TCP/IP updated is a common version when people talk about it today. Link layer in original is broken into the two layers: physical layer and data link layer. Translate the internet layer name to the network layer name. Okay, each layer in TCP has a specific function. So let's go top to bottom to explore. The application layer provides interface between the software running on the computer and network. For example, HTTP, TLS, SSS, HTTP is a service defined by application layer. Actually, application layer does not define the application by itself, but it defines the service that application needs. For example, HTTP defines how the web browser can pull content of web page from web server. The transport layer is responsible for delivering data end-to-end, and it guarantees delivery for the across network using mechanism error recovery. Transmission Control Protocol (TCP) and UDP datagram protocol are commonly used on the transport layer. The network layer provides several features, importantly the addressing and routing. One major protocol is the Internet Protocol IP. We are going to talk about IP addressing and routing later. Okay. The next is data link. Data link layer provides the rule to handle transmission of data, for example, error notification, flow control. It ensures that the message are delivered to the proper device on the LAN using the hardware arrest, and we translate the message from network layer to bit for physical layer. And physical layer, the last layer, do two things. It send bit and receive a bit. Bits come only in the value 1 or 0, and the physical layer communicate directly with the type of communication media, for example, AZ45, optical cable, so on. Okay, now let's explore how TCP/IP model process packet from top to bottom. With example, each layer do its job by adding the header to the data supplied by higher layer. For example, at step 1, the create and encapsulate the application data with any application layer, for example, HTTP header, and the data from application will move to the transport layer. Transport layer at step 2 encapsulates the data of application, use a TCP header or UDP header depending on the end user application, and the transport layer plus data, we call it a segment, and the segment we move to a network layer. Network layer encapsulates the segment using the IP header. IP header define the IP address, identify each computer on the network, and we call IP and data on the network layer is the bucket. The bucket move to the step 4 as the data link. Data link encapsulates the data inside the data link layer and trailer header. This layer use both header and trailer, and after that, at step 5, the physical layer encode the signal onto the medium to transmit the frame to destination. Okay, yeah, it's important when we focus on the work done by a particular layer, the encapsulated data is unimportant. For example, a IP packet can have the TCP/IP header and the HTTP header after the TCP header, and the data of web page after the TCP header. However, when we discuss the IP, we just care about the IP header, so everything after the IP header is data. Then with the drawing IP bucket, we just drawing the IP header, and everything after the IP header is data. Okay. The next is the OSI networking model. The International Organization Standardization took the task to create the OSI. OSI models has goals to standardize the data networking protocol to allow communication among on computer across the world. During 1990s, companies began adding OSI and TCP to their integral networks, but by the end of the 1990s, TCP/IP has become common choice and OSI fell away. The OSI models developed several in the past because slower format standardization process compared with the TCP/IP, so it never succeed in the marketplace. However, the OSI model did not win. Some the original protocol referenced by the OSI model still exist, and some terminology still remain in use today. Because OSI did had well-defined set of functions associated with each layer. If you know those functions, you can understand what people mean when they refer a root or function of OSI layer. For example, some guys talk about routing IP or routing protocol, so you can understand they are talking about network layer as OSI networking model. Similar to TCP/IP, each layer on OSI provides its service, and lower layer encapsulates the higher layer data behind the header. But OSI use another term, protocol data units BDU. BDU represent a bit that include the header and trailer for that layer. For example, a IPv6 will encapsulated by layer 3 BDU. It means the layer 3 BDU. Okay, the OSI model has many similarity to TCP/IP model from basic conceptual perspective. It has 7 layers and each layer define a set of networking functions. The OSI layer is refer multiple protocol and standards that implement the function specific each layer. In other case, the OSI did not create new protocol or standard, but refer other protocol that were already defined. For example, the IEEE defined Ethernet standard, so OSI did not waste time specify a new type of Ethernet. It simply referred to IEEE Ethernet standard. A particular TCP/IP layer is similar to particular OSI layer in a general comparison, but not detailed comparison. The comparison is literally like comparing a car to a truck. What can get you from A to B, but they have many specific difference, like a truck having a truck bed in which to carry a cargo, right? Both of the OSI and TCP/IP network layer define logical addressing and routing, but the addressing has different size and routing logic even work differently. So a comparison of OSI layer to another protocol model is general comparison of major goals and not comparison of specific methods. Note that a network device must actually understand the protocol at multiple OSI layer. When we talk about device, we normally refer to layer involved in the performance its core work. Example, router can operate at layer 2, but its main function belongs to layer 3. It's addressing, routing protocol, routing table, so on. So when we discuss a router device, we almost think it operates at layer 3. Okay. The next concept I would like to mention is Ethernet. The term Ethernet refers to an entire family of standards. So some standards define specific how to send data over a particular type of cabling and at a particular speed. Other standards define protocols, rule that Ethernet node must follow to be part an Ethernet LAN. All the Ethernet standards come from IEEE and include the number 802.3 as beginning part of standard name. Today, Ethernet includes many standards for different kinds of optical and copper cabling. Also, for speed from 10 megabit per second to 100 gigabit per second. The standard also differ as far as type of cabling and allow length of cabling. The most fundamental cabling choice has to do with the material using inside the cable for physical transmission of bits, either copper wire or fibers. The using of the unshaded with the pair UTB cabling ceremony compared to optical fiber. With Ethernet not use the wire inside the cable to send data over electrical with the circuit. Fiber optical cabling more expensive, allow Ethernet node to send line over fiber. Although more expensive, optical cable allow longer cable distance between nodes. Many Ethernet UTB cable using RJ45 connector on the both ends. The RJ45 connector has a physical location into which the AY in the cable can be inserted. Call it the pin option or just simply pins. The pin creates a place where the end of copper wire can touch the electronic inside the node at the end of the physical link so electricity can flow. To complete the physical link, the node needs the RJ45 Ethernet board that smart RJ45 connectors on the cable, so That connector on the end of cable can connect to each notch. PC often include this AZ45 Ethernet board as part of a network interface. AZ45 cable and AZ45 connector connected using 8 pin. Normally, pin 1, pin 2, 3, 6 used to transmit data if the bit is 10 or 100 megabit per second. And if the bit is the 1 gigabit per second, 4 more pin used. Pin 4, pin 5, pin 7, and pin 8. Today, there are two standards to mapping AZ45 cable to AZ45 connector, standard A and standard B. With standard A, the order of wire connected to AZ45 pin is white, green, green, white, orange, blue, white, blue, orange, white, brown, and brown. With B, the order is white, orange, orange, white, green, blue, white, blue, green, white, brown, and brown. So there are two types of cable used to connect device together: straight through cable and crossover cable. A straight through cable is cable using same AZ45 pin out standard as both ends. Crossover cable is cable use different AZ45 pin out standard at both ends. So straight through cable, pin 1 end of cable will connect to pin 1 at the other end of cable. Similarly, pin 2 connect to pin 2, pin 3 connect to pin 3, pin 6 to connect to pin 6. With the crossover cable, pin 1 will connect to pin 3, pin 2 will connect to pin 6, pin 3 will connect to pin 1, and pin 6 will connect to pin 2. Pin 6 will connect to pin 2 of outer end of cable. Crossover cable usually for using between switch and switch connection or router and router connection, and straight through cable using for switch to router or router to PC. We are talking about the pin for the speed 1 megabit or 100 megabit per second. If the speed is 1 gigabit per second, one pin need be used with straight through cable connect each pin with same number of pin on the other side. Pin 1 connect to pin 1, pin 2 connect to pin 2, and up through to pin A connect to pin A. With 1 gigabit over crossover cable, we need the 2 pair. One pair at pin 4, pin 5 connect to pin 4 and pin 5, and another pair is pin 7 connect to pin 7 and pin 8 connect to pin 8. Okay, we are talking a lot of things connecting AZ45. However, actually, whatever strand or through or crossover cable is unimportant between device on the real world production. This is because device can negotiate together which pin are used for transmitting or receiving. It means if we use straight through cable to connect two sheets each other, connection really operates 100%. Okay. I believe CCNA cover a large amount of theoretical content, but today enough, right? So I think you can understand what I talk, and I should stop video here and see you in next one. I would like to talk about IP addressing, Ethernet LAN, and MAC address as well. Before go to first lab LAN, VLAN and spanning tree. I hope that you like and you subscribe my channel, friend. Thank you and bye bye.